This time we're going now to talk about non-parametric methods. So, first, when we talk about parametric tests, these are statistical tests for population parameters that involve different assumptions, and the most common, not the most common, but the most, shall we say, assumption that should be met almost all the time if we're going to do parametric tests would be the assumption of normality, such as z-tests and t-tests. They should always have met the assumption that the population where the sample came from is true or approximately normally distributed. However, statisticians have developed a branch of statistics known as non-parametric statistics, or a distribution-free statistics, to use when the population from which the samples are selected is not normally distributed. Also, most parametric tests require data to be of interval and ratio measurement, but non-parametric techniques or non-parametric statistics do not require the data to be of interval or ratio level, which is helpful in some of the tests that we would need. So, a non-parametric test should be used instead of its parametric counterpart whenever data are of nominal or ordinal scale, or if data are of interval, but one or more assumptions such as random sampling or normality are not met. So, we have those different kinds of tests that are counterparts of the parametric methods that we had before. Now, since non-parametric techniques or methods have been developed, they can be used when the variable is not normally distributed, because although almost a lot of variables are normally distributed, not all. So if the variable that you're talking about is not normally distributed, then it will be helpful to use our non-parametric methods. Also, if the data are nominal or ordinal. Also, we can perform these non-parametric statistics if they do not involve population parameters. Sometimes also, the computations are easier if you do it manually, and there are fewer assumptions. And even further, since we do not need to meet the normal distribution requirement, the sample sizes can be very small. However, they are less sensitive to their parametric counterparts when the assumptions of the parametric methods are met. So if we figure out that they're normally distributed, no need to use the non-parametric methods. Go directly to the parametric methods. Also, they tend to use less information, especially if the data is of nominal or ordinal level. And they are, apart from being less sensitive, they are less efficient. So once the assumptions are met, more or less, better use the parametric methods. If the assumptions are not met, that's the only time that you use the non-parametric methods. Almost all the time, the one thing that you need to test is the normality of your data set, whether your data came from a population that is normally distributed or not. And these are some of the tests that you can use to test for normality: Kolmogorov's-Smirnov test, Shapiro-Wilk test, and the Sharp-Bera test. Now, let's try to do this one because we have an add-in that we have downloaded so that we can do this in Excel. Alright. Now, Excel doesn't have that, what do you call this? Excel doesn't have that built-in formulas for us to do non-parametric methods and even test for normality. Excel doesn't have that. So that's why we downloaded an add-in called XLSTAT so that we can use the non-parametric test. And you can also use this for other testing. Although, this is still part of the free trial. Once free trial ends, I'm not so sure which tests will be available and which would not. Let's just see once that once the free trial ends. Now, what we're going to do is we have to show that this data set, the amount of metal in parts per million, we're going to test whether or not this came from a normally distributed population or not. So how do we do this? We now go to non-parametric tests and we do distribution fitting. So here we select our data just like how we do in parametric before. We select this one here. Now we want to test what type of distribution is this, and we want to test whether it's normal. So labels are there. Now XLSTAT gives a different kind of result than the usual data analysis. So it's better if we give it on a different sheet. Although if you would like it to stay on the same sheet, you can just click page. But me, I would like to go give it a different sheet, so I'm going to stick here. So just other options. Here you can see that the test that will be done is Kolmogorov-Smirnov. There you go. And then the outputs, I'm going to also put descriptive statistics. And then I'm going to also to put histograms. So there. So that we can just see. So from there, we click OK. Then this, we just click continue. So here. So we have this. This is the reason why I would like to click on different sheet, because this is something difficult to remove. Now, first, we are given summary statistics, the sample size, the minimum, the maximum, the mean, and the standard deviation. From the data, we're also given the estimated sigma, and the estimated mean, and then the estimated sigma. So we're also given this, the parameters, the statistics estimated on the input data and computed using estimated parameters. And then we have our Kolmogorov-Smirnov test. Now, one thing about XLSTAT is that it also gives HO and HA and the actual result. Now, the Kolmogorov-Smirnov test gives us the test statistic, the p-value, and then the alpha. Although we did not change the alpha, it's usually 0.05. So, our null hypothesis is that it follows a normal distribution, and the HAH, it does not. So, again, the normal distribution, maybe we should make this bigger. There you go. The null hypothesis for this is that the sample follows a normal distribution. HA, it does not. Since the p-value is less than the significance level of 0.05, we reject. And although this is statistically wrong, we don't accept, we just conclude the alternative hypothesis. So maybe not accept, let's just change it to conclude. We conclude the alternative hypothesis. Now, the reason why I've showed the histogram is because it should show, this is how we can show if it's normal or not visually, but as we can see, it is not normally distributed. So, that is one example of doing Kolmogorov-Smirnov test to determine whether our data set is normal for us to determine whether we're going to use parametric methods or not.